First, let me apologize. I just wasn't thinking clearly in showing you the schematic, but I had it rotated 90 degrees. I apologize. I will try to avoid that situation. Here I've taken the transceiver and I've installed the BFO components as outlined here in green. Also, you'll note that this is because I had 2 years of kindergarten. I'd stay inside the lines and stuff. I also have a index here showing you that which phase, if you want to call it that, anyway, what each phase and what I was doing. First we did the auto amp, then we did the mute, then we did the BFO. Now one of the things that'll happen, and this happens to me, as in my former call, I gave all my lab stuff to a charter school, including a 1-meter telescope and a 12-inch Dobsonian. So my lab just pretty much depleted. Now I'm trying to replicate it again, and it's just going to take some time. So I don't have all the parts. So, well, for instance, here there's a 30 picofarad trimmer cap. Well, I have some 130 caps, and that's just too much. So what I'm going to do is, if you don't have a variable, just put a fixed in there. Now, this variable is probably capable of going from 5 to 30 picofarads or whatever. So I just plopped in an 18 picofarad. The whole purpose of this cap is to offset this 4.0 megahertz frequency from the 4.0 megahertz in the BFO of the transmitter. And whatever that offset is, that's the tone you're going to hear when you transmit, because you're listening to your transmit signal. It's offset from this. The product detector here is going to generate a tone that's the difference of those. So you just pick whatever value will give you a tone that you can tolerate. Also, Steve Weber in his design here picked an IF frequency of 4.000 megahertz. Now I'm pretty sure I have some 4.000 megahertz crystals somewhere, but I couldn't find them, and I don't want to spend a week looking for them. But I did find 4.032. Is there a problem with 4.032? The answer is no. It's just that originally 4.0 and the VFO starts at 3, so that means that this transceiver will start at the lower end of 47.000 and go up. If I really want to get down to 7.0001, then what I've got to do, since the IF frequency is 4.032, then the VFO has to start at 7 minus 4.032, which is 2.968. How do I get this down to 2.968? Well, I can increase the capacitance, or I can increase the inductance. The easiest thing to do is to go and calculate. We'll do it when I get to this part, but calculate and figure out what number of turns that I have to add to 27 to get this to work at 2.968. So I'm going to go ahead and use the 4.032s. I also have some 4.096s. I could use those. Then I got to just add some more turns to get this thing lower. Problem with that is if I got it lower, it probably wouldn't tune as much. Now, I know people make a big fuss on VFOs tuning the whole band. I'm not a big fan. I'm more interested in stability. And as QRPers, we're going to stand near the stand. We're going to spend most of our time near the watering hole, so enough of that. On the 1N5235B, it is indeed 6.8 volts. I have some Zener diodes that I just recently purchased, and they're in an envelope. I have two envelopes because I got them from 3 to 40 volts or whatever. This is a range of 3 to 12. What's nice is these came from China, and each individual string or whatever of these diodes are marked. So this is a 3 volt Zener. Its part number is 1472A, and it's a 1 watt instead of a half watt. So for what I need 6.8, here it is. The part number for a 6.8 volt Zener 1 watt is 1N4736A. All I have to do is just plug it in there because nothing else will change. It's just capable of handling more current. So it's just going to cruise, being a replacement for a half watt. So here it is. We're going to try it out here. From now. Oh, I asked you a question, didn't I? With this thing operational, how are you going to determine it's working? The way you do that is either with a frequency counter, or we can use a general coverage receiver. Now, I haven't tried this, I haven't fired it up yet. Let's do it. I don't need the speaker because it's not going to generate any tone. All I need to do is fire it up. Let's see here. I got a piece of, I thought of this earlier and didn't do it. Let's put something over the diode there because it's blinding. And we're off and running. Okay, here I've got this. I've got a general coverage receiver here. I don't even know. I don't remember the last time I used it. Now this thing, 2104, I don't know what time it is because I don't have a clock here on my desk. That would be 9:04 local, I think. Maybe close. All right, let's send the antenna here. Let's turn on and see what band it's on. Oh, looky there. Huh, okay. I must have been using these crystals somewhere else, but there it is. It's oscillating at 4031. Let me unplug it. It goes away. And I hear noise. Let me plug it back in. So there it is. It's working as advertised. And everybody should have it. Let me check this thing. What is it using for batteries? Because I know that I haven't used this thing in a long time. Oh, 3 Duracells. Oh, those things are good for 15 years. Oops, no, they're not. This is why you need to check things from time to time, because there is, this battery didn't do that. I don't know when I did that. Okay, I'm sorry. I need to clean that up. All right, that's another job for the lab. Okay, so that works. Now I also have a frequency counter. Let me get a 9-volt battery. Oops, I heard, a transistor came out of that. Oh, I use these little ramekins. These are 2 ounce for storing solid stuff. I need my test clips, sorry, for the arm here. Another thing about these things, I don't know if I ever explained to you, but I make these up myself. I purchased from eBay a bunch of these alligator clips or test clips, and I use them all over the place. Let's see here, I got a ground. Let's go over here to, I put a extra pin here for ground, friction fit only. And let's take the input to the frequency counter. This is my favorite frequency counter in the entire universe. This was manufactured by Doug Hendricks and the NorCal QRP Club 30 years ago, and it is very good. In fact, I'll show you how good it is in a sidebar sometime. Now, where is the output for this thing? It goes to Q4, doesn't it? Okay, here we go. Boing. 4.031989. Now, when a frequency counter or any counter is oscillating like that, the real frequency is 4031.9895, or you just figure out the ratio there. This, we'll see, it shouldn't drift, but it could change frequency because I'm breathing on it. These things are very temperature sensitive. All right, and it wound up at this frequency because I used an 18 picofarad there for C37. Okay. Was there anything else that I wanted to discuss about that? And I don't remember. But it's okay. Now, we're ready to move on to next phase. What do you want to build next? Well, it's time to get to do the product detector. Now that's going to consist of 1, 2, 3, 4, 5, 6 parts. So that'll take no time at all. Now it's 9 o'clock, so I'll just do it tomorrow morning, sometime early. Look here. Oh, that did turn off. I just wonder how long this receiver has been going all by itself, because it was in the deep, dark confines of a drawer. Oh, one other thing that you need, if you do not have it already, you need this component checker. It checks everything. Let me just show you how it works. Here's a resistor I just pulled out of a grab bag. This is a collection of parts that just somehow wound up there. Get one of these if you can find it. So anybody that's a 3D printer expert, make one of these. Send me an email and I'll send you the plans. Okay, I'm going to just bend this thing. That's standard spacing. Plug it in here, like so. Close this. Push the button. Now this is a 2.2K. Whoops, sorry. So that resistor is 2.18. So that's off 2 and 200. That's within 1%. It's a 5% resistor, but it's within. Now the reason why you need one of these is because I measure everything. I found out that Dave AA7EE also does the same thing. But looky here, and I did this a while ago. I have this box of capacitors I purchased off of eBay. Might have gotten it off of Amazon, but you got a ton of these monolithic capacitors. Now, this crystal, the BFO there, required 100 picofarad, required 2 of them, so I took 2 of them out of this little section here, and I measured them. One of them measured 93 and one of them 88, so I took another one, and it measured 90, so I took the 88 and the 99 to put them together and put it in the BFO. But in the process of picking one of these up, I dropped it. So there's 100 picofarad in one of these boxes. Now I always look at the numbers, but I need to measure them also. And it's just a good idea to check to make sure the manufacturer didn't mix up something and mislabel it or whatever. It's an OCD thing, and I apologize. It takes a little extra time for your project, but it's time well spent. Okay, I've gone 15 minutes. I'm sorry I ramble. I apologize. I'm going to go off and build the BFO tomorrow. Good night. Thank you. Once again, I'll beg you for a like.